In talking about polynomial functions of higher degree, we're going to be graphing these things, and we're going to need to know their end behavior, what's happening at the very left-hand side of the graph and what's happening at the very right-hand side of the graph. We're going to be answering two questions. We're going to be talking about what f of x, or what the function picture looks like as x goes to infinity, that's on the right side, or as f of x where he's going as x is going to negative infinity, and that's on the left-hand side. We're also going to be discussing x-intercepts. There are other names for this. We could call them zeros, solutions, or factors of our polynomial. So we're going to look at these things on the graph, and then we'll discuss in behavior. We're going to find patterns in these polynomial functions. In looking at these patterns, we have our polynomial function, and here he is. He's kind of a messy looking thing, but all this means is that I'm looking at the function, and n is my highest degree that's in the polynomial, and he's sitting of this form. A sub n is my leading coefficient. So I'm going to be talking about, when I'm talking about n behavior, just this guy right here. And if you have an n that is even, so n is even, then we're going to have the n behavior that looks like this on the ends with some bumps in the middle. I don't know how many, but it'll look like that on the ends for a, or my leading coefficient a sub n, greater than 0. If my a sub n is less than 0, the n behavior will be going down. It will look like this, and that is my a sub n is less than 0. So let's look at a few of those graphs for even function. Here is an x squared. Notice that my n behavior as x goes to infinity, and this is my x-axis here, so this is positive infinity on this side, and then we have negative infinity over on this end. So what I basically have is my n behavior. Both of them are going up. This is another x squared. All I did was just put a negative in front of the function that I was graphing earlier. And notice that as x is infinity over here, my n behavior is going down. And when x goes to negative infinity, I also go down. So I would say that f of x goes to negative infinity on the right side, and on the left side I would also say the exact same thing. I would say that f of x is going to negative infinity here as well. So let's look at a fourth degree polynomial. A fourth degree polynomial, and as x is going to infinity, right here, there's positive infinity, here's negative infinity. As x goes to positive infinity, we would say that f of x goes to infinity. And as x goes to negative infinity, once again I'd say that f of x goes to infinity, because the left-hand side is going up and the right-hand side is going up. So the end behavior on a polynomial function, if they're even, they're either both going up or both going down, depending on what the leading coefficient is. I'll look at the negative version of this next, and it should both ends be going down. I graphed the negative of our previous function. I just put a negative in front and then graphed it. And we see that because the leading coefficient is negative, the end behavior shows that both ends, both the left and the right, are going down once again. So just looking at this once again, if I have an even function and my leading coefficient is positive, the end behavior is that we have both the left and the right side going up to positive infinity. If the leading coefficient is negative, I have both the left and the right side going down towards negative infinity. We're going to look at odd functions next, and we're going to see for an odd function, I will have n behavior where one goes up and one goes down. I have few bumps in the middle. This is for a leading coefficient that is positive. If my leading coefficient is negative, I will have this case, where the left-hand side goes up and the right-hand side goes down. And this is for a sub n less than 0. So let's look at that on some graphs. Here's a cubic function. Notice on the end behavior, as x goes to infinity, we're going up, and as x goes to negative infinity, it is going down. You would say that f of x goes to positive infinity and f of x goes to negative infinity on each end, depending on which one we pointed out. Let's look at the negative version of this, and we'll see it flip-flop on its direction of pathway. Alright, here's the negative version. So for x going to positive infinity, we would say that f of x goes to, as x is going to positive infinity, that's way out in here, we would say that f of x, or the function itself, is going to negative infinity. For x going to negative infinity, for this particular function, since we have our negative as our leading coefficient here, we would say that f of x goes to positive infinity, because he's going up on the left-hand side. And basically, this just says the left-hand side. X going to infinity, that just says the right-hand side. That's what that notation means. Here's a 5th degree polynomial. I just put him up there so you could look at him. Notice that he's 5th degree, so he's odd. So we'll have one side going up and one side going down. Since I have a positive leading coefficient, the right-hand side is increasing and the left-hand side is decreasing. Sometimes you'll hear books describe it in that way. It is a 5th degree polynomial, so it has at most 4 of these little bumps in it. And you can just count them: 1, 2, 3, 4. Our 3rd degree polynomial had at most 2 bumps. A 7th degree polynomial has at most 6 bumps in the middle on its little pathway to do our end behavior. The next thing we're going to talk about in our polynomial functions of higher degree are x-intercepts. Now, sometimes you'll hear x-intercepts being described as zeros, solutions, or factors. So if you're asked to find any of that, that's basically what they're asking you to do. So let's do some of that. The very first function we looked at, our even function, was x squared minus 2x minus 3. So I factored that for you. And we would see that its zeros or solutions, or these are called factors, would be at x equal 3 and negative 1. So let's look at the graph and see that that's where our x-intercepts are. Alright, I've graphed that function for you, and you can see that my x-intercepts are at 3 and negative 1. And that's pretty important information when you're going to graph a polynomial function. If you could know what the ends were doing, what the x-intercepts were doing, and then eventually the y-intercept, and how we'll do that is just plug in a 0 for x, which is what we discussed last time. You'll be able to get your x, y-intercepts, know what the end is doing, so you just kind of be able to fill in the dots if you plot a few extra points. Here's the fourth polynomial degree function that we looked at. I have them all factored out here for you. X equal negative 2, negative 1, 1, and 2. That would be my x-intercepts if you were to factor him out. Then let's look at him on graph. Here he is on a graph, so we can see his x-intercepts: negative 2, negative 1, 1, and 2. Those would be considered the zeros, the solutions. They would be factors, or we could call them x-intercepts. Next thing we'll talk about is multiplicity. Multiplicity just means how many times does that 0 appear in your function. For each of these, I have a multiplicity of 1 because only one time is that listed as a factor. Here, I have x equal to 1 with a multiplicity of 2. Because the 0 x equal 1 is listed twice because it happens to be at the second power. So you can just look at the degree and count how many times that 0 appears. Let's see what happens on the graph. All right, here's x minus 1 raised to the second power, the entire thing. My 0, x equal 1, has a multiplicity of 2. So it doesn't go through that x-intercept doesn't cross through it. Instead, it touches it and turns it around. So let's change this to a cubic and see what happens. Now we have x equal 1 being our 0, and it crosses through where x equal 1. Now let's raise it to the 4th and see what happens. Alright, so summing up our multiplicity, it will touch the x-axis and turn around if it is an even multiplicity, and if it's an odd multiplicity, it will just cross that x-axis. We'll learn how to find zeros and x-intercepts a little more thoroughly in the next section.